So for number one, if I want you to find g of 10, that means we're obviously going to have to use the g function. Remember, function notation is g of x. So if you see this 10, what that's telling us is let x equal a 10 in the function g. So if we go to this function g, it's a -3, and then instead of x plus 1, it's telling us that our x needs to be a 10. So we're just substituting a 10 in for the x. Whatever that now evaluates to be is our answer. So I would now say g of 10 equals -3 times 10 is a -30 plus a 1, which is then a -29. All right. B, I'm asking you to use f. So here obviously is the function f. So now you have to use that function, and wherever you have an x, we're simply plugging the 3 in. So instead of x squared, I'm going to be plugging in a 3 squared, and then tack on an additional 7 to whatever that would be. So our functional value for f when x is 3, you would do 9 plus 7, which is 16. All right, C, you go to h. So here's now h. Instead of 12 over x is a -2. So we would just say our functional value for h when x is a -2 is a -6. Next one with just a regular old number, just so we use all 4 functions. Here's j of x. So if I want j of 7, I'm going to use the j function. That is now 2 times x plus 9. Our x now is told as a 7. Add 9. So j of 7 is 14 plus 9, which should be 23. All right. So you've done that before, just function notation, finding their values. The next one's just so we can kind of drive that point home and don't freak out when there's now not numbers. What you're simply going to do, here's h. This is what you're plugging in for x. So it's going to look weird. You're not going to get a numerical value for it, but instead of 12 divided by x, you are plugging in whatever is right here. So instead of 12 divided by x in my denominator, I'm plugging in an a. So it's really just 12a. So not a number, it's just an expression, but that is your final answer. All right, this looks weird. All right, if you go to f, same idea. Go to the function g. So we look at our 4 up here. Here's g. G is normally a -3 times x and then plus a 1. But instead of x, you're plugging in, well, a composite is what that's called. Whatever our composite is, that's what we're plugging in. So we are now going to replace this x, where I have my empty parentheses, with just a b plus a c. This, when it comes quiz, test, whatever, when it's multiple choice, I'd expect you to clean that up a little bit so we can distribute this. So we would get a -3b. That's the first product, and then do a -3 times c is a -3c. And then we would do a +1. You get 3 terms. None of them are like terms, so that's just your final answer. That's all we can do with that. Okay. Now, h, I, and j, a little different, so we want to make sure that we understand function notation. Again, here is g of x. So what I want you to do in a, just copy that function down. So just rewrite g of x is equal to a -3x plus a 1. Notice how in this case, you aren't told what x is. So we don't know what x is. But what we are told instead, this is now a little bit different, don't we know what g of x equals? This is telling you that g of x is equal to 16. So that means I can come down here to this g of x, and don't we know what that value is? It's 16. So what I'm going to do, I'm just going to erase this because I know what g of x variable is. It is a 16. The variable that we now solve for is x. So now you just have this little equation where you're going to subtract 1 from both sides so that we get 15 on the left equals a negative 3x. I think we all know we divide by a negative 3 in the final step. So 15 divided by a negative 3 is a negative 5. All right. Okay, I. Same thing. Try I now. See if we understand this one. This is one that you haven't done a ton of. You would have done this a little bit in Math 1, but it's not a big focus. See if you understand how we can now evaluate this. Find x if you know that h of x is equal to a negative 2. Now, solving it might be a little trickier, but see if we could at least do the substitution. All right, so here's h of x. I just rewrote the function. H of x is equal to 12 over x. What you were then told is that we know what h of x equals, right? So I can erase that and replace it with an actual numerical value. What h of x is equivalent to is a negative 2. Oh, I don't need it to be 3. Now, solving that's a little trickier. It's not one that you would have done a ton of, but I now want to solve that equation. And why this one is a little bit trickier, notice how your x is in your denominator. We don't really want the x in our denominator. So what we're going to do is multiply by x. So we're going to undo division. So you're going to multiply both sides by x. So multiply the other side by x. These are going to cancel. That's why we did it. And what we then get on the other side is a negative 2x.
Oh, by the way, sorry I was late. The Google link wasn't on my campus at all, and I just realized that Mr. Google had sent the link.
Okay, yeah, that's weird. I don't know because other people had that issue, and when I go to my page, it's still where it's at. So I don't know what's going on, why your guys aren't seeing it.
When I checked, there was no link at all.
I believe you. I don't not believe you because other people have had the same issue, but I don't know, have no idea why that would be.
Yeah.
So
it's really strange.
It is strange. Well, just like Friday, we found out the minus signs weren't showing up on some people's computers, and I thought it was their computer issue. But then we got an email this morning saying that had been resolved because apparently it was, for a lot of people, they weren't seeing it, not just a couple people in our class. So I don't know. It was weird.
Yeah.
Technology, you know. All right. Then from there, we can now divide by negative 2. That's the third person to say that. Mr. Kuwitz. All right, and then multiply or divide. 12 divided by negative 2 should be negative 6. All right, last one. Do J. Now we should be able to do J. This is a much easier equation to solve once you've done that substitution. See if you can get through that one. I wonder if that's it. Yeah. Maybe they emailed me. Check. Yeah, Alexander's not on. I got 4 emails. Is John Glasscott on? Can you look? Massimo? Nick is on now. Alexandra Draga Giannopoulos. Okay. Shoot. Yeah, if you don't mind. I need Alexandra, Massimo, and John Glasgow are all still missing, and I have emails from them that they don't have the link. Yeah, Cam, question, or you need me the answer?
I got the answer.
All right, what do you got, Cam?
4 equals x.
Good question. Let me see. Sort of. This is what you struggled with this whole time, right, Cam?
Oh, plus positive and negative 4.
Good. Yeah, there's two answers to this, right? F of x equals x squared plus 7. We know f of x.
I don't know why.
You do. You've done well the last quiz with it. Let me erase these if it'll let me. And I'm going to erase that f of x. I'm going to plug in a 23. No, I'm not. Then we're going to wait. X squared plus 7. Yeah. Subtract your 7 over. We're going to get 16 equals x squared. Even before we formalize this, you could have answered this question without understanding square roots. Aren't there two numbers that would solve this equation? Can't I square 4 to get 16 and a negative 4 to get 16? So that's why when we create our own square root here, there's actually two solutions to this, the positive square root of that number and the negative square root of that number. So we would want to do a positive and a negative 4. Okay? All right. One day, Cam, it'll be second nature. All right, last ones here. Probably we'll get through today. Giving you this function, you're going to fill in your table. And then this kind of now gets at the idea of what we're finding when we do function notation. Okay? So for this one, it says f of x is 3 minus 4x. And then we're just going to plug in these values to figure out what our functional value is. So I'll write the function over here. Oops. So what we're going to do for the first part is we're going to let x be -6, -3, 0, and then a 1. So plug in your -6. Have any of them come on yet? Massimo got on. Alexandra got on. Okay. Let me know when they're all on. If they all get it. John Glass, that's the last one. All right, and then a -4 times a -6 should be a positive 24. So this should give us a positive 27. Okay. When we go to do our next one, so let me erase this.
Is there a way we can plug this in our calculator?
There absolutely is. Because I was going to give you a shortcut here in a minute, because this is kind of an old idea. But yeah, if you were to graph this in your calculator, and I would pull my calculator up, I think you guys have all seen how long it takes to actually go up. But if you graph this, so just graph this equation, 3 minus 4x into your calculator, then go to your table. These values will be filled in for you, -6, -3, 0, and a 1. Okay? Now, here's our shortcut. Let me do one more, then we can start talking about something you would have learned last year, -3. So now this is f of x. We get 3, -4, -3 is a positive 12. So that's now 15. Remember how linear functions? Well, let's do one more. Maybe we don't. Let's do it the old way, just to make sure we don't get confused. So that should be 15. Plug in your 0. That should be super easy, because that's just going to give you a 3, because the -4 times 0 will be a 0. Plug in your 1. Also should be a nice one, because now you're just going to get 3 minus 4, which is a -1. But be careful. You can't really see that very good, can you, Rebecca? Be careful with that next x value. Notice we went up 3, then we went up 3, and then we went up 1. So do not assume this is a 2. Okay? Do what we did earlier. Let me go back up to this original function. Make this an x. Yeah, it's like a delayed reaction for me. And take what f of x now equals. Doesn't f of x in this case equal the negative 5? So we're going to let the f of x become the negative 5. So I'm going to erase this and replace it with that value of a negative 5. And then very nicely, don't we now have the variable x to solve for? And that's what this table still needs, is the x coordinate. So we're going to subtract that 3 over. That'll cancel. We get a negative 8 equals a negative 4x. Divide by negative 4. And what we should get, as these cancel, is that our x value would be a positive 2. So it actually does end up being a positive 2. Okay? Okay, you could then graph those. I'm going to trust that we can graph these points. We'd have to change our scale a little bit anyway, but that pretty much is going to be a wrap. So have this for tomorrow. We're going to finish those next. I think there's 2 more pages. None of them take particularly long without going over those quizzes. Shouldn't be a problem. So those who didn't get on today, I don't know what that problem is. I promise you that my link is still here. So I don't know why it's not. Oh no, that's my intervention link. That's really weird. Okay, yeah, I'll get that posted. I don't know how that. Oh no, right here. So it's still here. I don't know why you guys are not seeing that. So I would save that. So those 4 or 5 people, however you found it, maybe save it in a different location. And if you can't find it on our Canvas page tomorrow for whatever reason, have it available someplace else where you can find it in case for whatever reason it's not showing up on yours, because I don't know what the problem was. Okay, so sorry about that. Okay, no homework. We're all good. Have a good day. We'll see you guys tomorrow.
I didn't print out the notes, so I was doing this on a separate sheet of paper. Should I label it module 4.1, or is this just a review?
It's